everybody, welcome to this Insight webinar dedicated to Industry 4.0, from smart system integration to smart people ecosystem. My name is Olivia Huguin. I am Innovation Advocacy Officer at Blumorpho and one of the happy partners of this Insight project, and I will be your moderator for this webinar today. But before introducing our guest speaker of today, I would like to make a few technical comments. First of all attendees are on the listen-only mode, which means that you are currently muted. However, you can send your questions throughout the webinar using the chat box on your screen. And the last post I want to make is that, of course, the slide that we are presenting today will be shared with you all later on. A few words about the Insight project. Insight is a European coordination and support action which aims at fostering successful integration of smart systems in a broad spectrum of products and applications. And the major objective of Insight are to secure the position of smart system integration as a key enabler for innovation, to support and develop the smart system community in Europe. That's why we are very happy to welcome you at this webinar today, and to open new market opportunities for smart system integration by better understanding the needs of the demand side. So this is also why your questions are very welcome. So this project aims at unveiling and promoting new functions and advantages enabled by the integration of smart systems in pre-existing products and processes. But maybe a definition of what a smart system is can be useful. A smart system combines cognitive functions with sensing, actuation, data communication, and energy management in an integrated way. The enabling principles are nanoelectronics, microelectromechanics, magnetism, photonics, chemistry, radiation. And this is a knowledge base which separates smart systems from systems which are purely reactive. The provision of a safe and reliable autonomous operation under all relevant circumstances is a necessary or even increasing condition for smartness. So if smart system integration has obviously to do with Industry 4.0, it is also important to highlight that entering into the digital revolution is neither obvious nor simple, and that it raises many human and technical strategic challenges that we will deal with today. The digitization is a real issue in Europe because we know that according to the Digital Economy and Society Index report in 2018, provided by the European Commission, only 1 in 5 companies in the EU are highly digitized. And there are also many big differences across sectors and across European countries. And there are also many differences according to the size of the company. So that's why the European Commission set up what they call the Digitizing European Industry. This is a very ambitious plan to help our European companies to enter into their digital transformation. And the platform of national initiatives taken in this domain are gathered also by the European Commission to facilitate and foster the European companies' digital transformation. And during our webinar today, we will have the testimonies of 2 industrial companies that are already facing the human and technical challenges in dealing with their digital transformation, and I thank them for having accepted to share with us their experiences. This webinar comes after a series of other webinars which have already examined different aspects of the smart system integration, and you can access those webinars on the Insight website with the slides and the recording that are available. So let me now introduce you to our speaker of today. We will first hear Cédric Nguyen, who is a digital company manager at Cruze. Hello, Cédric.
Hello, everyone.
As a digital company manager or chief digital officer is some form of an evangelist whose job is to preach around the gospel of digital transformation. He is there to explain today, as well as to help the company teams on a daily basis in their job changes. The crucial question for him and for his company is, how do we comprehend the digital revolution by basing our paradigm on use before tools, data before processes, and value before technology? He will tell us more about that later. And we will hear also Stéphane Saller from Festo. Hello, Stéphane.
Hello, everybody.
Stéphane studied mechanical engineering with a specialization in microsystem technology at the University of Stuttgart. Since 2011, as a research and development engineer at Festo, he has been primarily involved in the development and investigation on novel sensor technologies, and he has done valuable work in the field of thin chips in the project COSIF, and then as a project coordinator, he is the project coordinator, of Parsifal 4.0. He now uses this experience to further develop and establish the technology of thin electronic system and intelligent films in an industrial context, especially for CPS and I 4.0 system, and he will give us a few examples of the challenges that he is facing. And we will also hear Géraldine André-Augustin, the CEO of BlueMorpho, who will give you some precious insight on how to get some help to enter your digital transformation.
Hello, Olivia. Thank you for inviting me today.
Welcome to this webinar. So, Cédric, the floor is yours. Oh, sorry, I have a few questions. Before giving the floor to Cédric, I would like to ask you to answer a few questions, because now you know who are your speaker today. We would like more about you. We would like to know, what is your smart system integration profile? Do you know about it, or are you totally new in this on this issue? I give you a few seconds to answer this question, which will be very useful for the Insight project to know better who you are. So the result of this questionnaire will be shared with you also with a slide at the end of the webinar. So now I would like to thank you for your answer, and I will ask a second question. How would you assess your level of interest in implementing smart system solution?
So, Olivia, I see that people are voting. It's very interesting to get their feedback. Very good to have this capacity to interact with the participants.
Yes, and
actually it's quite useful also for us as speakers, because we can better understand your expectation and also prepare your answer to the questions. So that's good.
Yeah. Thank you very much for your answer. And the last question for the moment, so where do you perceive the main added value in smart system solution? Is it a way for you to open in your market? Is it intelligent solutions, new sensing functions, autonomous solutions, or connectivity? What are you expecting from the smart system you want to integrate?
And Olivia, is it about Industry 4.0 especially? So where do we see the value of smart systems, especially for Industry 4.0?
Yes, of course. Yeah, definitely. What are your expectations in entering into the digital transformation?
Okay.
Thank you very much for your answers. And now I shall give the floor to Cedric. Cedric, the floor is yours.
Okay, thanks. When we met the first time, Olivia, you asked me if it was easier for us to start digital transformation because we are a company with a technological background, and I answered to you. Even if we have, as you said, technological background, it wasn't easy for us to jump into digital transformation because we were used to provide technological solution, technological product to our customers, but it doesn't mean we are able to provide a technological solution and explain them to our internal teams. So as you can see on the slide to introduce Cruise, we are a B2B manufacturer, we are a long-term market player, we are a medium-sized company, and our headquarters is located in French countryside. So clearly, there is no question, Cruise is not a GAFA, but still, we decide to move on with digital transformation. So why? We work on digital transformation because we think digital is a huge, major revolution for industry, and this is a future for our company and for all the company. So the first thing we did when we started this approach more than 1 year ago now, and this is the first advice I can give to any companies which want to move on with this topic. We define, we formalize a clear definition about what is digital transformation. Because if you ask to 10% what does digital mean, you're going to get 10 different answers, I'm pretty sure. So what we decide is, this is just a Cruise definition, not a universal definition, but we formalize it to be clear with our own team. There are 4 points. The first one is, for us, digital is for the whole company. That's why we include in the approach purchasing department, finance department, HR department, and of course, factory or industry 4.0 is a huge part of our transformation. The second point of the definition, the second main point, is we want to be focused on usage, on use case, more than on technologies, because we are a manufacturer and we didn't plan to become an IT company. We don't want to play with technologies just for fun. The third point is, and really related to the previous one, we want to stay focused on added value. Which value are we able to provide, to bring to our teams? And the last main point of our definition is about information and data. I'm not the first one to say that, but data is the oil of the next century. So it means you have to provide the right data to the right persons at the right time. I'm pretty sure you already heard about ATAWAD, anytime, anywhere, any device. So after saying that, the question is, okay, but what are you doing daily? So today we have a small digital team internally, and this small team is working on 3 different axes, as you can see on the slide. The first one is project management. Firstly, we help IT and business teams work together. We coordinate projects with technological stakes. Secondly, we identify the evolutions of the organization because, of course, you will have evolution of organization related to new technologies, new usage, new way of working, way of collaborating. So the purpose is to support these evolutions and keep the global consistency into the organization. The third axis we work on, last but not least, the change management. Because of course, if you change the way of working, the way of collaborating, way of designing products, way of collaborating internally, but also externally with your partners, of course, you will need to support, to train, to support the change with teams. Explain also what you are doing. And these three pillars, these three axes, are not independent of each other. So, for example, talking about Factory 4.0, because this is the topic today, we have a project currently. The project is to set up touch screens on the shop floor in our factories. So in this project, we have defined physical and technical constraints. We have coordinated external partners for hardware, for example. We have managed tests with users. So we definitively pilot the project. So pilot project management. Secondly, in this project also makes the process of information sharing between engineering and manufacturing teams evolve. So you have to endorse these new processes and take into account new way of working, again, new way of collaborating, new way of thinking of the teams. And moreover, the point in this project was not only to move from paper to Word document, but the purpose is to provide enriched content to the operators to help them work better and better day after day. So the purpose is to provide to the operators video, 3D CAD model, assembly simulation, and so on. So this requires you to support the team to handle the change management and train operators and so on. So as you can see, this is just an example, but you have the three axes into this simple example. And I'm pretty sure when you're going to look other technologies and use case, augmented reality, cobotics, big data, and so on, you have to consider these three aspects of the transformation if you want to success. So just to conclude my quick my quick speech, I want to share with you two main pitfalls. The first one, when you want to start, you have to find the right use case. Again, you want to be focused on value. You want to be focused on what you can really bring to your team. So think about where do you feel pain in your organization, the right use case. And the second point, the second pitfall is find the right technological partner, because as I said, we are a manufacturer. We don't want to become IT player tomorrow, and I'm pretty sure a lot of manufacturers don't want to become IT players tomorrow, because you cannot integrate all technological skills at the end. So find the right technological partner if you want to go quickly and properly. And this is a transition to the next speaker, I guess.
Okay, thank you, Cédric, for this really interesting presentation on the challenges you have been facing in this very exciting and demanding digitization process. Géraldine Andrieux has a question for you.
Yes, actually, Cédric, I just really enjoy your presentation, and I just have a question for you. How long did it take you to make this transformation, the digital transformation within your company? And how would you consider the current steps?
Okay, it's we are still working on the digital transformation. So we start almost 2 years ago now, and the plan is to continue working on during the next at least 3 years. Because I think the main part of the transformation is not about technologies, is really about the mindset of the people. And I compare digital transformation very often with the lean manufacturing, because it's not you cannot say I have a target and when I will reach the target, this is the end. I'm totally digital. It's over. It's a continuous improvement, because new technologies will come, new use case will arrive. You have to just train your teams to understand and handle the continuous change.
Yes, so we understand it's really, as you said, acculturation and change management. And have you done it fully by yourself within your company, or do you collaborate with partners around to do it?
Both. We collaborate with partners, but to be totally honest, I think for specific technological projects, as I said, augmented reality or robotics or big data, you have to find external skills, because you cannot integrate all of the skills. But for the change management, I really think you have to pilot mainly internally, because you need people who knows the team personally, can spend time with them, understand their job, understand their mission. So it's really it's not easy to find someone external to manage this part of the transformation.
Right. So at the end, it's really a team building, and it's very interesting actually, because it's true that, and I think it's going to be also the next topic. It's true that to start, you need to make sure it's possible. So you need to find the right solution to do it, but then you need to integrate it. And I'd like to thank Olivia for the choice of this webinar, because actually it's true that integration is not only technical, it's also integration within the organization. So it's a very also important topic that we wanted to raise here. So thank you very much. And thank you for asking me the question. So.
Yeah. Good. Thank you very much, Cedric. So through your testimony, we've seen that part of the difficulty still is technical. So to enter into manufacturing 4.0, you need to find the appropriate technical solutions. And this is something our next speaker knows quite well. Stefan, this is your mission to address the technical challenges of Industry 4.0. And could you give us an example of the solution you have been working on and how to manage the technical challenges of Industry 4.0?
Yeah, thank you very much, Olivia, for your introduction. I want to take the chance in this webinar to to make the connection between Cedric and my topic. So he said that if you have difficult developments, you need partners and skills, and sometimes you need them from an external side. And this is why we are working in a funded project. It's called Parsifal 4.0, and Parsifal is an abbreviation for Product Capable Standalone and Secure Foil Systems for Automation Solutions in Industry 4.0. And as you can see, we have on the bottom line here lots of partners in a big consortium, and we identified a use case, and I think I will go to the next slide. First, we identified a major challenge in Industry 4.0, and there I can make a link to that what Cedric said. We need data for digitalization. That means, in our point of view, we have still a lack of necessary sensor data and connectivity in existing production facilities for having a transparency of our processes and optimization possibility. And our approach here is to make an upgrade of existing components in such facilities or on productions. And this is what we want to achieve with. We want to use some kind of smart sensor system label. So we make a refit of our components. So we don't just exchange them with newer technologies, but we want to make a refit. And what that means and the challenges is what I want to talk about in the next few minutes. I think the general challenges of smart systems and their integration is they have to be easily integrated in hardware that's already there, and so we need a small footprint and a good form factor. Also, we need to have some kind of multi-platform character. That means a smart system consists of hardware and software and a variety of functions. And then another topic in Industry 4.0 is we need some security and secure mechanisms to have a secure communication and use open protocols. Another approach can be integrating low power strategies for having autonomous systems. If you think about a big plant, sometimes it's just necessary to give only a status flag of a system that it's running once a day. So you don't need such an intelligent system, but you just need one flag that's still running, and then you can build a low power system. And also we need the expertise and experience in engineering, and this is why we have a big consortium of different partners, and each of them is facing its own challenges in the context of Industry 4.0. So Festo is taking the lead of this project. We are the coordinators, and our approach is making production facilities more efficient by refitting of components with such sensor labels. Also, we want to do predictive maintenance and offer cloud services in the end. Our partner that's doing lots of technology development is IMS Chips, as a research partner. He's thinning down silicon chips. What that means, I will explain afterwards. So if we use foil systems or flexible, small technology platforms, we need small chips that are integratable into foils. Another partner is Bosch. They want to upgrade their packaging technologies with MEMS sensors. So they want to detect whether a package has fallen on the floor, if there's any damage, such things in logistics. Another research partner is Hanchikart. They are working on the architecture of Industry 4.0 and an energy harvesting topic here in the project. And if we look further, we see TDK Micronas. They are developing thin Hall sensors. We need them for our foil systems. I will explain later on that. Then we have Infineon, who's addressing the security topics in our system. Root Microtech makes qualifications of the system, like cross sections of that foil systems, to get an information how good the integration of small systems or small electronic pieces in foils is working. Stackforce is working on a communication stack and a security roadmap. And in the end, our partner Virtu Electronic is embedding all those components in a foil. And as you can see, there's lots of technology here in the project, and therefore we need some help from our government to take some risk, because if you make a new development, you need resources. And therefore, we are funded by the German Ministry of Education and Research. And thank you. At this point, we have a budget of 8 million euros. We have 9 partners, and the duration of the project is 3 years. It started in November 2015 and will end this year. So we have done a lot, but there's still some challenges waiting for us. And now we can go a bit deeper into detail. I'm going to the next slide. So our project is driven by 2 demonstrators, one for automation technology. On the left side, you can see a pneumatic drive, pretty standard component in industry, with a refit with that sensor label I explained. And on the other side, we have a demonstrator from Bosch. They will also put a label on a package and monitor temperatures, humidity, and acceleration. So if some package has fallen down or the temperature exceeded some thresholds, like for drugs or something like that, then you get an information, yeah, you should take the newer product. Okay, having some picture of our architecture, we have our two demonstrators. I put a pneumatic drive on the left top side with a S3 label, our sensor label, and this is communicating with a gateway over 2.4 gigahertz and 6LoWPAN, that open protocol that's developed by, Stackforce. And all the sensor data like acceleration, position, temperature, humidity, light is going from the label to the gateway. It's authenticated, the communication, so you can be safe that the partners know each other and there cannot be any manipulation of the data. And from that gateway, we are going into the Festo environment to a IoT gateway. We can then go over OPC UA to any field device and automation, or we go by HTTPS to cloud services and show on dashboards the relevant data. Also, we want to attach open IoT platforms like Node-RED to connect easily and see the data, what's going on in our production. Okay. Let's go a bit more into detail of the hardware challenges, and our core technology here is from IMS chips. I already talked about our institute. They can thin down electronics. Electronics are usually on wafers that have a thickness of 400 micrometers, and they can thin down them up to 30 micrometers of a residual thickness, because the electronics is in the upper 10 micrometers. So we have still some substrate where we can have our electronics. And as you can see on the right side, this is a 30 micrometer thick chip that can be bent. And this is our starting point for the integration into foils. So we have chips from TDK Micronas, we have chips from Texas Instruments, we are using microcontrollers from EM Microelectronic and Ambiq Micro, and those chips are going in a embedding process.
Just a question, Stefan, why do you consider this a challenge? Why is it the key challenge of your project, the thinning of electronic components? Is it very strategic for Industry 4.0?
I think you need it for making thin foils. You need thin components, and what's special about this is you have CMOS electronic in a foil. Normally, robust electronics are organic electronics like printed electronics, but they are not so much power. They are not so fast than electronics based on silicon, and this is pretty unusual to have thin silicon chips in foil, and each chip has different properties if they're coming from TDK, if they're coming from Texas Instruments. So finding the right thickness and keep the system functional after the thinning process, this is a big challenge. So that they're still working if they are mechanically changed. So that's the main point here. And also the process has to be developed and optimized.
And that's really aligned with Industry 4.0 to get faster access to data and to integrate it everywhere, basically.
This is true, yeah. So we are coming from the hardware side and building Industry 4.0 products. That's the idea. And the idea behind everything is we want to develop foil systems to have a pretty easy refit of components that are still existing or already existing. So we don't make a pneumatic drive with every function. We just put a tape of intelligent electronics on that pneumatic drive, and then we have a Industry 4.0 product which can help to build a cyber-physical system. Okay, on that slide you can see the integration of such a small chip in a system, in a foil system called Interposer. In the middle there's a a radio chip from Texas Instruments, and you can see here connections going out. They are growing a bit bigger. This is used for if you have this small sheet of foil. This is just 50 micrometers, and this is embedded later at Wood Electronic in a bigger foil made out of liquid crystal polymers. And it seems like I have small problems with my mouse. This small foil interposer is then going in a PCB process. This is also a challenge. The main problem here is to have a compatibility between the chemical stuff in the chip world and the chemical stuff in the PCB world. Okay. When we talk about automation, we mainly move stuff. So we have a pneumatic drive with a piston rod and a piston here. And you can see there's some kind of magnet. And if the piston rod is moving, the magnetic field is also moving and changing locally. This is where those Hall sensors come in. And one challenge here is if you have normal Hall sensors, if they go out of the fab, they will be calibrated one time and then they will work. If we have thin Hall sensors, the mechanical properties of that sensor is changing and we have some kind of warpage due to the thinning. So the chip is not flat anymore, it's a bit deformed. And this deformation has an impact on this initial calibration in the chip. So this is a problem because the sensitivity of the sensor is changing, and therefore TDK is working on a stress pixel IC. They will check with this IC how the stress behaves after this thinning. And if we have an information about the stress on a chip that is thin or maybe bent in the foil, we can have a strategy to have a new calibration then. This is here a big issue, and I think it's a pretty good approach to address the problems of thinning chips. Okay, the same idea is here done at Bosch. They address the packaging stuff, but also they are working on thin MEMS sensors like for wearables or applications like this. And as you can see, we had in the beginning just small chips. Here it's a bit bigger. This is a standard MEMS in a package. As you can see, here's an ASIC with the electronics and a spacer. We have a substrate, we have a cap and a MEMS structure that's mechanically, there are oscillations due to acceleration. And the idea is here to thin the cap down and the substrate. And what you can see in the middle, there's a cross section of this left structure, and they are coming down from the top and the bottom, and they managed to have a functional chip with 150 micrometers, and in the beginning it was around about 400 micrometers. Like in the Hall sensor, we also have here different mechanical behavior after the thinning, and this has to be solved. So this is still in progress, but we have some working samples here.
Right. Stefan, it's very interesting to see all the technical development that are required for Industry 4.0. To conclude your presentation, because I see the time is running a bit and we would like to get questions also from people, could you highlight also what is very critical and focusing on what is very critical for Industry 4.0 development and has to be developed at the chip level as you're doing here?
I think thin chips is still a problem. The integration has to be solved. But if we have in the end processes that work, like having thin chips from different manufacturers, it will be pretty easy to build systems of different properties. Like you can build everything you want because these are just normal chips you can order everywhere. So the process development, I think that will be a big step forward for having easily integratable smart systems everywhere. and not only on the hardware side, but also on the software side. This is why we integrate like security, open protocols here in Parsifal. I think it's a combination of both. This is what I think will come in the future. So there are still open questions. We are not finished yet, but I think it's worth working on that. What you can see here is a small foil system with an integrated chip. We have here a cross-section of a small silicon chip with 30 micrometers, and there's a copper connection. This is something our partner Würth Electronic is working on. So how much time is still left?
You just have like 1 minute, sorry for that.
Okay, I'm almost finished then. Let's go. Cross-section you have already seen, but let's go then to our vision and our current status. This is what we have in the end. We have Hall sensors on that side. We have thin and flat electronics on the top. And working all together, we get information about our cylinders, our process, if it's still running good and fine. And this can be the end. Where's the picture? Here. So this is a normal picture of a production site. And what you can see here is a small sensor label, which can be easily attached on a component. And then you can exchange data that we use and need for Industry 4.0.
And are you planning to make a demonstration and to show the results you obtained from this development?
Sorry,
are you planning to make a demonstration of the system, because we can really see how the chips are now integrated on the system? So
yeah. This is planned at the end of the year, and at the end of the project, we are working to get our demonstrators running. And the first thin foils and the first thin chips are already manufactured. They have to be put together, and we have 4 months left to make a complete demonstration. So this is our goal, and this is what we are working on.
Great, very interesting. I'm actually, that's also very aligned with what I wanted to say, because I have to admit that I a bit jumped in this webinar when I heard it's about Industry 4.0. So I'm here to explain a bit more about public and private financing for Industry 4.0. And it's really aligned with just what you just both said, because what I wanted to highlight here is that at Blue we are working with a lot of different players. It's a large corporation, private investor, research organizations, startup, SMEs, and large institutions, also the European Commission. And we have noticed in the few last months that the interest for Industry 4.0 has really increased, also from private investors. So, and we believe that is thanks to projects like you are running, to show that it is working, to show that companies are really successful in implementing Industry 4.0 in their company, that now we have a very strong interest from private investors ready to engage with companies providing differentiation and attractive solutions to make Industry 4.0 really happening. So we wanted to highlight that. So if you are looking for funding, that's also a good opportunity for you to enter into the Insight project, because we can help you to find your way. And two also think very interesting, you just mentioned some development or some example of what is possible to do with technology for Industry 4.0. And there is new scheme of support for European companies in Europe. This is what we call the Innovation Actions. And basically, it's acceleration program for companies, SMEs. It could be startup. It could be also small companies that are already existing, but are looking for implementation of robotic solution. So there is a program running currently. If you want to have more information, just contact us. This is also the goal of Insight, to highlight financial support for you to use smart systems to enter into Industry 4.0. So Robot Union is one. And we have additional one, like you mentioned, cyber-physical system just before. And there is also support from the European Commission. If you want to get access to cyber-physical systems, to integrate it into your smart solutions and smart systems, you can benefit from the European Commission support. So you can have access to technology, you can have access to business support, and it could be also to define how to make this innovation happen in your organization. So again, through the Insight project, we wanted to highlight that you should totally have a look to Industry 4.0 because you can also have strong support to do it. And finally, I wanted to highlight that we have done previously a webinar with the participation of Petra Weller from VDI IT and the coordinator of the Insight project, where she really highlighted also the value of entering into the EPOS ecosystem, because you can also join good partners to build your Industry 4.0 project. And as Stefan highlighted, you need a lot of different competencies to make your project happen. So you can totally have access to the support through the Insight project consortium. And if you are looking for more information on public funding, you can have access also to this webinar we organized a few months ago now. So yes, I will just go on because I know the time is running fast. So again, as Olivia mentioned, this is part of smart system integration. And here again, you can see that in joining EPOS, you can have access to research priority, roadmap, research strategic agenda, and also take part to the policy positioning. So it could be also quite useful. You can have access to funding also, and through Horizon 2020, and also to the Excel projects and programs. So maybe we wanted also to ask questions to our participants today.
Yes. As I mentioned in the beginning of the webinar, we really need your feedback to know whether you would like to receive more information on Insight project. As Charlene just reminded you or tell us, is that the Insight project may help you in your digital transformation process to find the right partners. So please tell us if you want to get more information on this issue. Thank you for your answer, and we will get back to those of you who wanted. We will get back to you. And we have a last question. Please share your feedback with us to improve our process. How would you like to evaluate? How would you assess your interest in this webinar? No, sorry.
That's good. It's working. So
thank you very much.
Thank you very much. Your feedback are also very important for the Insight project, because we are preparing the final webinar for Insight, and we always need to get your feedback to know the topic you're interested in. So if you have any comments, if you have any questions, I think it's really the right moment to ask your questions, and also advices on the topic you would like us to raise in the near future through the Insight project. So do we have some questions? So we have questions about how the slides are available, and we can tell you that yes, the slide will be available. And more than that, we encourage you to go to the Insight project website, where you will see more information. Yes, we have a question from David, and I think this is a question for you, Stefan. Why thinning electronic has to be more system and invisible?
If I understand it right, why thinning makes the system smaller, right? No.
Yeah.
Because you are not bound to any PCB construction constraints. You can easily integrate foil systems everywhere, so you can freely design your mechanical components, or if you have existing mechanical components, then you can easily adapt your electronic system on the mechanical part. So this is an advantage.
Right. Okay, really interesting. I wanted also to highlight that you mentioned flexible electronics, and there is also some project running on flexible electronics to adapt the sensors to the form factor of the system you want to develop. So if you want to have more information on that, also we can share that with you also through Insight project.
Thank you.
Thank you very much.
So yes, I think we are done for our webinar today.
Thank you very much for joining us, and we stay in contact with you, and we'll send information and the slide of the webinars to all of you.
So thank you very much also for our speaker today and for your very good presentation.
Yeah, thank you,
much.
Cedric. Thank you, Stefan, for your very impressive presentation and for accepting to share your experience with us. Thank you very much.
You're welcome.
Bye-bye.
Thank you. Bye.
Thank you.